On part 3, we're going to talk about the natural logarithm. Now, what we've been doing was y equals the log base 10 of x. And sometimes you write 10, sometimes you don't. But if there's nothing written there, then it's assumed it's 10. Okay? Now, we have another logarithm that has a different base. And if it's base e, remember e is a constant. It's an irrational number. But if the base is e, it's so common that it got its own name, and it's ln, natural log of x. Okay, so that's what's going on here. So if the exponential looks like this, e to some power, then the inverse is y equals the natural log of x. And it's understood that the base is e if it's using natural log. Now, the thing is, it's still going to have that same point, and it's still going to curve like this. Okay. Okay. It still approaches right here. Has an asymptote of 0 because you're not going to get any negative results. Nothing negative. It still has an asymptote of 0. And the domain is still 0 to positive infinity. Nothing's really changed. All right. So that's the big deal. Now, with your natural log properties, they're going to look a lot like what we just did. Okay, this is the same. Natural log of 1 is always 0 because e to the 0 power is 1. Anything to the 0 power is 1. The second property, the natural log of e is 1. That's because if you swirl this, e to what power is 1. I'm sorry, e to what power is e? It's 1. Okay. Same here. The natural log of e to some power, because these two cancel one another out, you can cross it out. And you just get x. Same thing here. It's the reverse of that. E raised to a natural log of something cancels out, and it's just x. Fourth property, if it's a natural log of something equals a natural log of something, because these logs are equivalent, the logarithm part drops out, and it's just x equals y. So let's look at some of these. We can do these without a calculator, applying the properties that we know. All right, so if you need to, put an equals x so you can swirl. So it's saying e to what power is 1 over e? Well, your exponent's power should tell you that that's a negative 1. E to the negative 1 power is 1 over e. Number 2, e to the natural log of 5. Well, these two guys cancel one another out, so I'm just left over with 5. Number 3, it's 4 times the natural log of 1. Well, we said the natural log of 1 is always 0, right? E to the 0 power is 1. So 4 times 0 is 0. Done. 2 times the natural log of e. Well, we said earlier that the natural log of e is equal to 1. So this is 2 times 1, which is just 2. Natural log of e raised to the 1/3 power. Okay, so think about what this is asking. Don't get tricked by this. This is saying e to what power is e to the 1/3? Well, it's just 1/3. Okay. 5 times the natural log of 1. Natural log of 1, back to the same rule we just talked about, is 0. 3/4 times the natural log of e. Well, that's 1. Natural log of e is just 1. So 1 times 3/4 is 3/4. Number 8. E raised to the natural log of 7. Again, these two cancel out, so my answer is just 7. Natural log of e squared. You need put an x over there so you can see it's saying e to what power is e squared? Well, it's squared, just 2. E times the natural log of 1. Well, that's e times 0. Anything times 0 is 0. And number 11. E raised to the natural log of 1.8. Well, these two guys cancel each other out, so I'm just left with 1.8. Okay, so let's look at the graphing component of the natural log. So remember, our parent function, what does it look like? The natural log is doing this guy. Has that same point of a regular log function of 1, 0. All right, so look at this. The natural log of a negative x. Now the negative is on the inside here. So what is that doing? Remember, if it's on the inside, it's going to reflect over the y-axis. All right, this reflects over the y-axis. So instead of flipping down, we're not doing that this time. We're flipping this way, okay, across the y-axis. So this point that was at 1, 0 is now over here at negative 1, 0. And my graph is doing this business. All right? So my asymptote still is at 0. Okay? But what's my domain? My domain is now negative infinity to 0. The vertical asymptote is where x is equal to 0. And what's my y-intercept? It's now negative 1, 0. Right? It flipped. So don't confuse yourself over that. Look at the next one. What is this x minus 1 doing? That's going to shift it right 1 unit. Okay? So what the point that was at 1, 0 is now at 2, 0. It's now doing this. And that asymptote that was at 0 is now over here at 1. So think about my domain. It goes from 1 to positive infinity, 1 to positive infinity. My vertical asymptote is now at x equals 1. But where's my x-intercept? It got scooched over. It's now at 2, 0. And that's all there is to it, to the graphing part. Okay? We'll talk more about it in class, and see you then.